Hello, welcome to this first video of the DNA problem. And this first video we want to explore what did DNA change? What difference and what is new with DNA in the argument or discussion or investigation of evolution or change in understanding of origins. And to do that we want to start off with this gentleman right here. Many of you may recognize him even just from his photo. This gentleman is none other than Charles Darwin. Was born in 1809, died in 1882, and he wrote a book, and the book he wrote is called The Origin of Species by Means of Natural Selection. And this book was published, as we can see actually down here on the bottom, but it was published in 1859. And there are other people that had talked about evolution with different theories and different ideas, but he is by and far regarded as the father of evolution. And the important part of mentioning him and the father of evolution is that look at these dates. He was published his book in 1859. Then we move along, and almost 100 years later, in 1953, we have some more gentlemen whom you may or may not recognize from this photo. These two gentlemen here, and actually in the background we see some kind of weird setup there. They're actually trying to build a physical structure representing a molecule they were working on. And these two individuals happen to be James Watson and Francis Crick. James D. Watson, and Francis Crick. They discover the structure of DNA. They discover the structure of DNA, and they do that in, as I said, I believe 1953. And what difference does DNA make to origins? They've discovered DNA. What is DNA? What difference does it make to origins? And to explain this, I want to use an example on purpose. It's not a organic example. It's just if you were walking along in an area that you had not been before, and all of a sudden you come across something that looks like what we have in this photo here of some mud formations. I don't know if you want to call it mud structures, just a strange way in which mud is placed. Then you could wonder, well, why is these little straight pieces of mud in a corner and so forth? And you could begin really thinking very creatively with your mind, and maybe say, well, maybe the wind blew the first structure and put it in place, and then after that the rain kind of solidified it in that one place, and then the next time wind came by, because the one structure was there, it directed the wind. And when it rained, it directed the rain, and maybe there was long hot days and then some cold days, and maybe there was an earthquake, and you could have all kinds of explanations and trying to propose how this different formation came about. But if while you were digging around the mud structure there in the formation, you happened upon something that looked like this, a blueprint or a document, an abstract representation of those mud formations, then that would change the whole picture. We call this an abstract representation because it doesn't have mud on it, but it has lines and maybe some words and some indications. It might be in a different language. And DNA is kind of like that blueprint. It's kind of like that design information contained in an abstract form, so that just as the blueprint would explain the mud ruins, and in honesty here, I have to say this blueprint has nothing to do with those mud ruins, but it's just an example. But just as a blueprint would explain the mud ruins, so DNA explains the design of organisms. DNA, as the structure was finally discovered and clarified, is a series of nucleotide pairs. The nucleotides are only 4 types. It's A, G, T, and C nucleotides on the left side, right side, in a helix format shape, and they're joined together, and information is encoded in. If we go through and read, if it's the next one is an A on the left side, or if it's a G, or if it's a T, or if it's a C, and all that formed together at this point we know forms chromosomes, and chromosomes form actually explain the design of organisms. What am I referring to that? I have an example of a baby. It could be a lobster, it could be a wildflower, it could be a worm, anything like that. But the pairs, the nucleotide pairs, determine, like this baby here has hair, it has eyes, it has arms, it has fingers on the end of its arms, it can breathe, it can cry when it is hungry, and so forth. And all of that design, the way that that's going to work, the way it's going to look, the way it's going to function, is encoded, we understand now, in DNA. That's what's added to the equation. What does this mean? You may not like the word that DNA explains the design of organisms. We could cross out the word design and say structure. It's the function, the form, how the organism looks at the end of once it's formed. All of that is explained and determined by the nucleotide pairs in the DNA helix. If you don't like the word design or don't like the word structure, I don't know why those words make some people nervous in this case, then call it oomph if you wish. We can talk about the functionality without necessarily having to use a specific word. The functionality is very clear, and in a series of videos we will be explaining that functionality. So call it oomph if you wish, but it changes the whole equation. The most important thing that we would like to start out with in this first video is that since this has changed, since we understand that DNA determines the structure, function, building of an organism, changes to an organism, it's no longer, it's not about influences on the organism. Evolution and the theory of evolution was around almost 100 years before the structure of DNA was discovered, and what DNA did. And so we can give a little bit of leeway that they used to talk about evolution in different ways, but it's not about whether the bananas were in the trees or the grass was in the field. It's not about whether it was cold or hot, whether it was a volcanic gases in a lake, any of those issues. It's not about the influences on the organism. Whatever affects the organism does not change its design. It does not change its form. It does not change the way it is. It's now about the influences on the DNA. If the DNA information is in the DNA that makes the organism, then what changes the information in the DNA? If we're going to talk about evolution, if we're going to talk about changes in organism, what changes the DNA? Because we know that the DNA determines the organism. That's really the simple thing that we want to say, the DNA problem. Rather than explaining things and saying, aha, this is just makes it obvious that they just all evolved. Again, the discussion is about what changed the DNA, because the DNA is what builds the organism. And really, that's the only thing we want to cover in this video. We'll be having a series of short videos, and each one of them building on the previous one to show the points about the DNA problem. And we hope that you'll watch the videos, and we look forward to your comments and feedback.